Hi, this is how AWS VPC works introduction. In this video, I'm going to give a basic introduction to AWS VPC. Here are the terms you're going to need to know in order to be working with VPC. First, VPC, Virtual Private Cloud. Next, Route Table. Then there's Network ACLs, Security Groups, Subnets, IGW, which stands for Internet Gateway. Then there's NAT, Instances or NAT Gateways. So when I was first introduced to VPC, I actually dragged my feet a little bit. AWS was still in EC2 Classic, and then they came out with EC2 VPC. And I was like, oh, another thing? Because I kind of like the simplicity of EC2 Classic. It wasn't another thing I needed to deal with. But AWS knows what they're doing, and there are some advantages with VPC. Basically, you have more control of the network, and you have more security at the network now. And nowadays, VPC is such a fundamental component of AWS that if you're working with AWS, you really should have a basic understanding of it. All right, so the second thing was, when you're given a laundry list of terms, it's very difficult for me to comprehend. So instead, I'm going to try to explain this with a diagram. So here's a simple VPC network diagram. And this simple VPC network diagram is based on two links, which I will include in this presentation also. But basically, it follows best practices, and it's a simplified version of that. Because for this tutorial, we don't have to build out redundant AZs. But in production, you should have redundant AZs. Okay, so first, the biggest block here, the enclosure, VPC. That represents your entire virtual private cloud. And it's required to be given a CIDR block. The /16 CIDR block represents an allocation of 65,000 IP addresses. So what the CIDR block is doing is how many IP addresses that I want available in my VPC network. And in this case, I want 65,000 IP addresses available. And then the next network component is our subnets. Here's a private subnet and here's a public subnet. So a subnet is exactly what it sounds like. It's a subset of the network. So the entire network space is 65,000. Well, this subnet with the /19 CIDR block will allocate 8,000 IP addresses for that subnet. And this other public subnet with the /20 will allocate 4,000 IP addresses. Now, the public subnet by design here is a little bit smaller than the private subnet because normally you have more private resources than you do have public resources. A public resources could be a load balancer or even a EC2 instance. A private subnet could be private instances and databases, for instance. So this is a pretty standard design here. Okay, and so what makes a public subnet a public subnet? Well, there's this other network component called a public route table, or a route table, but I'm making a public route table because of a route that we're going to add to it that is going to contain the internet gateway. So basically, to make a subnet a public subnet, you just have to associate with a public route table and add a route to it that contains a rule that allows outbound traffic to the internet gateway. I know that's a lot of words, but we're going to go through and actually build this VPC, so then that will hopefully help to understand it better. There's also this component called the network ACL, and this is what basically provides you with another layer of security. This is a firewire layer at the network level. So if you're a network person, you could actually control and block off access at the network layer. Normally, before in EC2 Classic, you would do that with security groups. But security groups is it's actually applied to not network components, but other resources like EC2 instances, RDS databases, and other things. So on the left side here, this is the private subnet side of the diagram. And what makes a private subnet a private subnet? Well, there is no association with the public route table, which is connected to the internet gateway. That's what makes it private. There's no association and no outbound rule in its route table to allow outbound access through the internet gateway. Instead, we're going to add a route to this private route table that's going to route the outbound traffic to this NAT instance. This NAT instance will then translate the private IP addresses to public IP addresses, but in a kind of private way without the internet gateway. So that way, you don't actually it's not public. Any resource in this private subnet is not exposed to the internet. The NAT instance in order to work, must reside on the public subnet. If you put the NAT on the private subnet, it's not going to work. So don't do that. Okay, so that kind of covers in a diagram all the components of a VPC. I know it's a lot of different components and moving parts. So it's just something that hopefully as we build out the VPC, it'll help you understand it. But also, I thought going through different diagrams and giving different perspectives of how the components fit together will also help understand VPCs better. So this slide is called Relationships Are Important in Life. And subnet relationships are very important too in the VPC world. So I'm going to explain this from the perspective of belongs to. What does a subnet belong to? A subnet belongs to a route table via a subnet association. A subnet can also belong to a network ACL via a subnet association. And a subnet can belong to and only belong to, when you create it, one AZ. So that's the perspective from belongs to. Hopefully that helps. If that doesn't help, let's try from the other direction. Thinking more about relationships, because relationships are important in life. So this is from the has many perspective. So a route table has many subnets through subnet associations. A network ACL has many subnets through subnet associations. And AZs can have many subnets also. So hopefully these different diagrams and perspectives help you kind of connect the dots and understand these network components better and how they fit together. A couple of extra miscellaneous notes before we jump into building this VPC manually is the internet gateway. The internet gateway, where does it fit into the picture? Remember, it's added as a route to the route table, to the public route table, and then you associate subnets to that public route table, so then that those subnets become public because of that association. Okay? And security groups, they belong to actually an entire VPC. Notice in the network diagram, I'll jump back to it, there's no security group here. Instead, security groups belong to the entire VPC, and they're assigned to resources like EC2 instances, ELBs, RDS databases. They're assigned at that type of resource level, not a network component level. This is a segregation of different firewalls. One security group firewall off different components. And going back to the diagram, a network ACL firewalls off network components. So that's the security feature right there. All right, so now we are going to jump into building a simple VPC. So I've taken the first diagram and overlaid it with these numbers here. So these numbers indicate step by step which component we're going to build first. So first we're going to build the VPC, then we're going to jump into the public subnet, then the private subnet, then public subnet, then we'll build the internet gateway, we'll create the public route table, number 5 here, and associate the internet gateway with the added internet gateway route to this public route table, and associate the public subnet to this public route table. That's what makes the public subnet public. Once we associate that public subnet with the public route table that has a route with outbound rule to the internet gateway. I know, that's a lot of words. Okay, and then on the next step we're going to do after that is number 6, we're going to create a NAT gateway, and then create a private route table, and then set up the association with the private subnet to the private route table, as well as an outbound route to the NAT instance, so then EC2 instances or resources in the public subnet can talk to the internet also, but through the NAT. All right, let's jump right to it now finally. Okay, so I'm at the VPC dashboard. I'm just going to go to services here so you see how to get to it. Networking and content delivery, VPC. So now we're at VPC. Then you can click on your VPC here. Then we'll do create VPC, and I'll just call it test VPC. And the CIDR block I'm going to provide is 10.10.0.0/16. That's going to allocate about 65,000 IP addresses. Tennessee, do not do dedicated. It basically is a dedicated network, and it costs a lot of money. So don't do that. Use default, unless you are sure you absolutely want to do dedicated networks. Okay, so now step 2, let's go back to it, is we're going to build the private subnet. Let's go build the private subnet now. The private subnet, we'll go in here and we'll create, I'm going to just call it private subnet 1. And I'm going to assign it to the test VPC. And AZ, I'm going to put in the US West 2 AZ. The CIDR block now is 10.10.0.0./19. So that's going to allocate about 8,000 IP addresses for that CIDR block, for the IP space right there. And that's creating the private subnet now. And I'm going to go ahead and go to the next step now. So the next step is creating, and I'm going to go ahead and have this up here so I don't have to jump back and forth through the slides. Okay, so the next one, we are going to create the public subnet. So go ahead and click create subnet, call it public subnet 1, test VPC once again. AZ, I'm going to put in the same AZ. By design, I'm doing that right now. And then with this, you need an offset because the first subnet already used up some of the IP space. So now you have to kind of shift it over, and that's the offset that you need in order to create the next allocation of IP space. Okay, and this is going to allocate about 4,000 IP addresses. And we're just waiting for that to spin up. Okay, so let's kind of sort this. So there's the public subnet 1 and private subnet 1 that we just created. And check this out. This is very useful. It shows you how many available IP addresses are in that subnet. And it is about 8,000, about 4,000. It's also important when you're creating the public subnet to make sure that you enable this right here. Auto assign public IP. So we're going to go here and go modify auto assign public IP. And you click enable and click save. Or else, let's say when an EC2 instance spins up on this subnet, it's not going to allocate by default a public IP address, which you want one in that case. You can override it when you're launching the instance, but that's the default setting. So that's important to set. Okay, so the next thing we're going to do now, and actually I'll go back to the slide so you can see, is we're going to number 4, we're going to create an internet gateway. So let's jump down to internet gateways, click create internet gateway. We'll call it test IGW and click yes, and it's detach. So you need to actually attach it to VPC. So let's go ahead, attach to VPC. Now it's attached. So we are good with that one. Next step. Next step is number 5, the public route table 1. So let's go create a public route table right here. You create a route table right here. I'm going to call it public route table 1. Also associated with the test VPC. Click yes, create. It's created. So now remember, what makes a public subnet public? Well, it depends which route table is associated with it, and it depends if that route table has a rule for outbound traffic to go through the internet gateway. So we need to set that up. So let's go ahead and set up the route here. You click edit, add another route. Outbound traffic is specified by this rule right here. And then now you can see that you can click on the internet gateway and save it. So now any subnet that's going to be associated with this route table is now going to be a public subnet. So you can go here, edit now, and then I'm going to select public subnet and save. There you go. So we've now successfully created this side of the diagram. Now let's onto this side. All right. So next step is the NAT, number 6. Let's go ahead and create a NAT gateway. NAT gateways are down here. You click on this, you create NAT gateway. You find the subnet, and we want this to be on the public subnet. Remember, if you put the NAT gateway on the private subnet, it will not work. So make sure you put it in the public subnet. Okay, and then here you need to allocate an elastic IP address for it. I'm just going to use this one, and then you create the NAT gateway. So NAT gateway is being created, and it even says right here, edit route tables. It's giving you a good suggestion to go edit the route table. So let's go to the route tables here. And this is the public route table. What I want to do is take a look at the private route table. So this is the private route table right here. Oh, there's no private route table yet. Duh, we haven't created yet. So the next step is creating the private route table. Create a private route table. And an important thing to note is the reason why I'm going through the length of creating route tables is because if you don't create a route table, if you want to modify your network access control, then what you have to do is you have to modify what's called the main route table. You see how there's a main here? That's like a default route table. Whenever you create a new subnet, by default, it's gonna be associated with that route table, unless you explicitly have associated with a different route table. So that means if you go and mess around with the main route table and let's say add a route to allow outbound traffic to go through the internet gateway, thereby making it public, any new subnet you create by default will be publicly accessible, which is not a great security thing. So this is why it's important to create our own custom route tables and associate those. So then by default, you are secured and you have to explicitly open up access. All right, so there, we've created the private route table, but we still need to associate the route with the NAT gateway. So let's go ahead and do that. 0.0.0/0. And then the NAT gateway is right there. And this is private route table, so that's good. I click save. Subnet associations. And we want to associate, again, the private. And see how it still says the private, again, just to confirm, is associated currently with the main route table because there's nothing associated with it. But we're going to override that behavior because we want more control of that. All right, so that is done. And now we have successfully done it. We have created this entire simple VPC network manually, and we did it manually just so you could see how it's done and learn the components. Let's summarize and cover what we did. To recap, we created a VPC, we created the private subnet, then we created the public subnet and enable auto-assign IP. So that's the default setting. Whenever instances are launched into that public subnet, it will, by default, assign a public IP address, which is what you want. Then we created an internet gateway attached to our VPC. Then number 5, we created a route table, a public route table, and then we added a route for outbound traffic to go through the internet gateway. Then we created a public subnet association, so then we finally made that public subnet public. All right, and then number 6, we created a NAT gateway. The NAT gateway is going to allow basically internet access from resources that are in the private subnet. And then we created a private route table. And remember, it was important to create these extra route tables instead of relying on the main route table, because by default, new subnets are launched into the main default route table. And if you override that and open it up to the world, then by default, your new subnets are going to be exposed to the world. And that's not a very great security design. So finally, we created the private route table, and then we added a route for the NAT, and then we added association for the private subnet. And that completes this whole diagram. Okay, so I have some questions at the end here that you should hopefully be able to answer now to hopefully help you understand VPCs. These questions are, why should we create our own route tables instead of using the main route table? That should be pretty fresh in your mind because I just covered that in the last slide. Should the NAT gateway be in the private or public subnet? Putting the NAT gateway in the wrong subnet would make it not work. So that's important. What makes a subnet public? And what network component is a security group associated with? All right, so hopefully you can answer those questions, and hopefully that gives you a better understanding of how VPCs work. Here are some resources that I referred to earlier, and this is what the simple network design was kind of based on. It's just a simplified version of a recommended best practice for VPC design. In real life and production, the tutorial that we went through is not production ready. It's only one AZ, so if that AZ fails, you're kind of hosed. You want at least 2 AZs. And I would recommend, if you really want to dig into VPCs, if that's your thing, try building one out yourself. Try going through this tutorial, because that's how you're going to really be able to learn. It's a lot of moving parts, and VPCs, there's just a lot of new material if you haven't worked with networks before. So I hope you enjoyed this video. I hope you found it helpful. If you found this video helpful, please be sure to like it to encourage more content like this. If you have any questions or any other video suggestions, feel free to comment below. And if you need any DevOps helps, check out BoltOps and subscribe to watch more video content like this. Cheers!